In this video, we will specifically talk about Kubernetes namespaces, and we will discuss 3 instances where Kubernetes namespaces don't work. Kubernetes natively provides the means to logically separate a physical cluster into multiple virtual clusters via namespaces. Namespaces are intended for situations where multiple users need to share the same Kubernetes cluster. They can be configured to ensure that each user or application exists within its namespace and is completely isolated from every other user of the cluster. Let us look at an illustrative example. As you can see in this cluster, we have a number of namespaces. Now let us look at the resources in the Datadog namespace. Note that we can also view all the namespaces and their resources in the Rafay console. Although namespaces are powerful, they are not viable for many common scenarios. Let us review a few of them. The first challenge is that of true partitioning. Although namespaces provided the ability to logically partition a cluster, it is not possible to truly enforce partitioning. What this means is that users or resources operating in the same cluster can access any other resource in the cluster regardless of the namespace it is operating in. The only practical solution is to use dedicated Kubernetes clusters to guarantee true separation across operational boundaries. Some of Rafay's customers, especially service providers, have a business requirement to operate large fleets of geographically distributed clusters. These can range from hundreds or thousands of Kubernetes clusters. These clusters are deployed to retail stores, factories, and hospitals, providing a managed application operations platform for application teams at these organizations. These customers use projects to compartmentalize operational visibility and access to their fleet. In this example, the fleet of clusters is logically organized into 3 completely isolated projects: the Americas, EMEA, and APJ. In addition, clusters in these projects can be configured with RBAC so that they are managed and supported by local operational teams to comply with regulatory and compliance requirements. Although all clusters may belong to the same organization, it is possible to dedicate different teams or business units to the projects. Given the scale and geographical distribution of a fleet, there is also a practical requirement to logically organize the clusters so they can be managed by regional operational teams that can provide timely local support. Some application teams are required to deploy their containerized apps to multiple geographies. This can be due to reasons such as regulatory and compliance requirements, performance, latency requirements, or availability requirements. Again, namespaces are not a practical solution here. It is also common for organizations to require complete isolation between their pre-production and production environments. Rafay enables our customers to organize their fleet of clusters into projects. In the example below, the customer has 3 active projects that are mapped to the operational environments: dev, staging, and production. Each project has dedicated clusters associated with it, and only identified and authorized personnel are allowed to access resources in each project. The second challenge is that of accurate chargebacks. Many shared services infrastructure operations teams are required to implement fine-grained chargebacks to dependent application teams. It is operationally cumbersome and challenging to use namespaces as the means to track utilization and implement chargebacks. Rafay's enterprise customers use and create projects for every business unit or application team they service. Each project can have one or many dedicated clusters. This provides the team with a simple and streamlined process to implement organizational chargebacks without any incremental operational burden. The third challenge is that of managing upgrades and versions. Some containerized applications have dependencies on critical software add-ons that are supported only on certain versions of Kubernetes. As a result, it may not be possible to upgrade these Kubernetes clusters before an updated version of the add-on is available. For example, some of Rafay's customers use Kubeflow, which is a critical software add-on for machine learning workflows. At the time of writing this blog and creating this video, Kubeflow was not supported on Kubernetes 1.16, which is 2 versions behind the latest version. Since namespaces are not a practical solution as a way to manage upgrades here, these customers create projects for machine learning applications with dedicated clusters that run specific versions of Kubernetes. Rafay supports a fine-grained role-based access model, ensuring that only authorized users and groups can have access to projects. Within a project, it is possible to configure roles to ensure separation of duties between infrastructure and workload operations. Users with a project admin role will have access to workloads and related resources. In contrast, users with infrastructure admin roles will have access to infrastructure and related resources. In this demo, Matt Ray is an org administrator. He has created 3 projects to support 3 different teams: the default projects, demo project, and an infrastructure project. As an admin with the highest privileges, Matt has visibility into all the projects. For the demo project, he has assigned John Smith as the project admin. When John Smith logs in, notice that he can only see the demo project. The organization has a shared ops and services team that supports all teams with infrastructure-related requirements. So Matt has assigned this group as infrastructure admins to both the demo and infrastructure projects. So when Chris Riley from the shared ops team logs in, he can view and manage infrastructure for both projects. In summary, this organization has used projects to create true isolation boundaries across 2 different business units.